Welcome back. In this video, we are going to solve example 5.2 that is taken from chapter number 5, Torsion, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is the shaft shown in figure 5-11A is supported by two bearings and is subjected to three torques. Determine the shear stress developed at point A and B located at section AA of the shaft in figure 5-11C. So you can see this is figure A and this is the shaft supported at the end by bearings and three torques are applied at that. So you have to determine the shear stress developed at section AA, and from figure C you can see you have to determine the shear stress at point A and B. So let's start with the solution. So first step is that if you section this shaft at this point and take the left side of this, the free body diagram is like this. Now from this free body diagram you can see, since the bearing do not offer resistance to the shaft, so the applied torque satisfy the moment equation. You can see this moment is 42.5 kips, that is counterclockwise. This is clockwise 30 kips. So in order to keep it balanced, here this torque will be also clockwise. So we will apply the equation of moment that sum of all moment about x axis is equal to 0, taking the counterclockwise moment as positive. So first moment is first torque is counterclockwise, so 42.5. The second one is minus 30, and this minus t is equal to 0. So from this t is equal to 42 minus 30. So let's calculate it. 42.5 minus 30 is minus 12.5, plus 12.5, and you can see that this 12 point t will be equal to 12.5. The unit will be kips into inch. Okay. Now you have this torque. So what we are going to do, as we know that this shear stress, the general formula is equal to T into rho divided by C, where this rho is greater or equal to 0 and less or equal to C, and C is the radius of this shaft. Okay, now for that T into rho divided by J, not C, sorry, this is J, where J is the polar moment of inertia. So first we will find the section property, that is J section property. I can write J is equal to polar moment of inertia and this J for this circular shaft or for circular cross section, this J is equal to pi by 2 radius power 4. So radius is C, so C power 4. So just plug in the value. So pi divided by 2 and C. What is the C of this? So from this diagram you can see the C is 0.75 inch. So I will put 0.75 power 4. So calculate it. I will calculate it here. C is 0.72 and we have power 4. So I will take power 4. That will give you this value, multiply by 3.1417 divide by 2. So you can see 0.422. Okay. I have taken 0.72, it's 0.75. So 0.75 power 4 multiply by 3.1417 divided by 2, 0.497. Okay, so we will take 0, J is equal to 0.497, unit is inch power 4. Now you have this J value, you have torque. So what you can do is that you can find shear stress at point A and B. So for point A, now here you can see rho is equal to C, because C is distance from the center till this point A, which is equal to 0.75. And I can say that this shear stress at point A is equal to T into C divided by J. So torque is 12.5, C is 0.75. I can write it over here 0.75 divided by J is 0.497. So again we will calculate this. So 12.5 multiply by 0.75 divide by 0.497 will give you 18.86. So we will round it off and we will take it 18.9 and unit will be KSI. So this is shearing stress at point A. Now for point B, we will take this rho is equal to, you can see from this figure C, this is point B and point B is away from this radius is 0.15. So we 0.15 inch. So shear stress at point B is equal to T into rho at B divided by J. So T is 12.5 multiply by 0.15 divide by 0.497. So when you calculate it, T shear stress at point B is 12.5 multiplied by 0.15 divide by 0.497 and that is 3.77. Okay, so 3.77 KSI. Clear? Now you can see that shear stress at point A is this one and shearing stress at point B is this one. The discussion of these stresses on each element A and B are established and the direction of the resultant torque will be shown. So we will show the results. So you can see that shearing stress at point A is this one and you can see that torque is in this direction. So what I will represent the shearing stress at point A, it will be like this. On this surface it will be like this. Similarly surface and this is the shearing stress and we can represent it that this shearing stress is 18.9 KSI. Similarly at point B you can see this is inner this portion of point B and the torque is in this direction, so shearing stress will be in downward direction and I can represent the shearing stress at point B will be like this. So lower surface they both will match and from this they will match and this will be shearing stress at point B and that will be equal to 3.77 KSI. So that was all about this example 5.2. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.